Okay, good evening everybody. I firstly want to introduce myself. I'm Dr. John O'Sullivan. I'm from the School of Civil Engineering and I'm the chair of the marketing committee that's involved in the organisation of events of this type. I want to welcome you all to UCD this evening. Some of you might find it strange that the College of Engineering and Architecture is hosting its main engineering information event in the Sutherland School of Law. The reason for that is that the event has increased in popularity over the last number of years, and we no longer have the capacity in our own building to host crowds of this size. So that has facilitated us being here this evening. In addition to that, then, we have the advantage here that we can stream our presentations on a live basis, and we have in excess of 90 registered people outside of this room that are also watching these presentations. So I must welcome those people here as well. We have four presentations this evening. The first presentation will be given by Professor David Fitzpatrick, who's the college principal. The second presentation will be given by Dr. Aisling Harkin. She's going to talk to us about careers in engineering. Aisling is from the UCD Careers and Development Centre. And then we've got two student presentations, one from a recent graduate and one from a current student. And they will give us a flavour, if you like, of what it's like to be a student in UCD and what it's like to be a graduate after you leave UCD. Just a little bit of housekeeping then before we get on with the main presentations. If everybody just takes note of where the escapes are or where the exits are. We've got exits on the left and right, and we've got exits up at the back. So in the event of something unforeseen happening, that's how we will vacate the room, please. So without further ado, I'm going to pass over to the first presenter this evening, and the first presenter is Professor David Fitzpatrick, the college principal. Thank you.
Okay, you're all very welcome. I hope you can all hear me. I'll take a little bit of time now just to talk about engineering in general, engineering at UCD, and then also to talk about our program structure and to give you some idea of the types and the breadth and scope of what we have within our programs here in UCD. Just to give you a little bit of context about the College of Engineering and Architecture, we're a very large school of engineering. We are the largest school of engineering in Ireland. We are 50% bigger than our next nearest if you like, rival, competitor, compatriot. And alongside that strong undergraduate and taught master's program, we can also see a very strong level of research activity. So 87 million euros worth of research funding has been generated within the College of Engineering and Architecture over the last 5 years. We have over 200 PhD students currently and over 3,000 publications across the last 5 years. So one of the things you should realise is that when you come to UCD to study engineering, you're not just studying a professional engineering degree programme, but you're studying under the tuition and guidance of academic staff who are intensely research active, who are leaders in their own field and have worked to develop a suite of programmes that will equip you to do what you would like to do in your career within the field of engineering. Some of you may have seen this video before. It's from Engineers Ireland. I'll just play it to give you some idea of what an engineering career might end up being for you.
Will you come with me?
Across bridges and railways.
To feel the Atlantic's wave power.
To brave new worlds.
From the rudder to the engines.
To making monsters.
These things are there for me and you.
From purifying water with reverse osmosis.
To stopping cells dying.
From apoptosis.
Multiplayer online gaming.
Clearing minds. And saving lives.
These things are there for me and you.
Chartered engineers, bringing dreams to life for me and you.
So one of the things you might notice from that video is that the traditional image of engineering as being a group of individuals who build bridges, create buildings, make roads and design cars and aircraft. That's still there, but we also are heavily involved in things that are vital for life. Water purification, health, technology, communications, all of those fields are where engineers play a role. Dilbert also has something to say on this. Let me, if I can get him to play.
Sitting here for nearly a minute without entertainment. Change the battery in the remote. The one on the left. The one on the left? Well, that's just spooky. Not really. I have the knack. The knack? For technology. My mom says I always have.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh! The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer.
No!
There. Don't blame yourself.
Will it go away over time?
It might, but pray it doesn't. If an engineer loses the knack, the results can be devastating.
And in further news, you might want to get out those...
Thanks for filling in for our regular doctor on such short notice.
I was in the neighborhood.
So maybe you have the knack. Maybe you like mathematics, you like science, physics, chemistry, biology. You like using your creative skills to dream up something new. Maybe you take things apart, put them back together again, and find out you still have parts left in your pocket and wonder why they still work. Maybe you are a natural engineer. Maybe you just like the idea of using creativity along with sciences and mathematics to be inventive and creative and haven't yet developed the area which you want to work in most. So why would you want to choose engineering in UCD? Well, UCD is one of the top 1% universities in the world. We have world-class engineering education, and we've received awards for the programs that we offer here, particularly our ME streams that have developed over the last 5 to 8 years. Nationally, we offer the widest range of degree options that are available, and we don't make you make that choice in your first year. You have the ability to stream progressively through our degree program. When you're engaged in our 5-year ME program, you then have the opportunity to avail of a 6 to 8 month internship, which develops links with major employers, and in our experience to date, then also creates opportunities for graduate employment directly following that. Part of our program is also structured so that you can sample modules that are not directly related to engineering. It's good if you choose modules that are linked to engineering. They fit and build on your capability, but literally you can choose anything from A to Z within the curriculum that's available in the timetable. And then finally, our degree programs are accredited by Engineers Ireland, who are acting on behalf of the Washington Accord agency. So our degree programs are recognised internationally around the world, from the United States through to Australia. So you can travel and use your engineering degree from UCD for gainful employment wherever you would like to go. The chemical engineering degree, I should specifically mention, is accredited by the IChemE, and our material science and engineering program is also accredited by the Institute of Materials. So when I say we have the widest range of degree programs, what do I mean? Well, this is the list of the full suite of ME programs: biomedical, biosystems, chemical and bioprocess, civil, structural and environmental, electrical energy, electronic and computer engineering, energy systems, engineering with business, mechanical engineering, material science and engineering, and structural engineering with architecture. common to all of those is the fact that you enter into a single degree stream, with the exception of structural engineering with architecture at present, I will say. So for all the other programs, you come in through engineering UCD DM150 and undertake a common first year which will cover the fundamentals in physics, chemistry, mathematics, electrical, electronic engineering, an introduction to creativity and innovation through the creativity and design module, and then you choose from a range of option modules that let you sample what the other areas and subjects offered within the program might be beyond stage one. At the end of your first year, you make the first of two choices you can make within the engineering degree program. So at the end of first year, you choose your initial stream that will determine your trajectory within stages 2 and 3 of our program. You choose then from biomedical, chemical and bioprocess, civil, electrical, electronic or mechanical engineering. And within that 2-year and 3-year period, or stage 2 and stage 3 period, you can then choose to have a semester or a full year abroad as well. At the end of your third year, you then make another choice, and that effectively is whether you want to progress within the 4-year BE program, which is our traditional engineering degree program offering here, or whether you want to move into the 5-year ME structure. And again, the full breadth of programs then becomes available within that 5-year ME structure. One addition that's particularly relevant for students who are commencing in September 2016 is that we will be starting a 5-year integrated ME in chemical and bioprocess engineering that will be accessible for students who start in UCD engineering in 2016. How many points do you need to get in? Well, points this year are never a predictor of points next year, but over the last couple of years we've been around the 500 mark. Last year, 500 points was the random selection point for entry into the mainstream engineering program. Structural engineering with architecture, points were slightly lower, 410 points for entry into that program. From 2017 entry, we will have a single combined entry route for engineering, the core common engineering programs and structural engineering with architecture, so that DM140 will no longer be available. You must have one laboratory subject, preferably chemistry, biology or physics. Students always ask, or prospective students frequently ask, what should I choose? Does it really matter? And I think probably it's fair to say most students come into UCD engineering with physics. Slightly less will have chemistry as a single science subject, and quite a few will have chemistry and physics. But some students arrive into UCD engineering having only studied biology as their lab subject, and they all do fine. So it requires harder work in first year, but as long as you have one of those, you're well positioned. So alongside the core subjects that we offer in your first year, you also then have the opportunity to sample the first of your elective offerings through the UCD Horizons program under the options that are available. And you might want to use your elective to choose other engineering options, as I've said, or to go and sample something different. Some students like to continue a level of language skill development because they've studied French or Spanish in school, for example, and they may elect to use their elective choices for Spanish or French in that case. How are you going to learn when you're here? Well, one of the fundamental pieces of the program is lecture theatre delivery like this, large group teaching, particularly in your first year, and then reducing as you go through the other years, where we'll impart the basic fundamentals around physics, chemistry, and mathematics, for example. We'll also start to show you how you can use those fundamentals and apply them to real engineering problems that are relevant for the particular degree stream that you're entering into. Typically, the lectures then are supported by laboratories, which gives you hands-on experience and lets you, see the theory and then see it in practice and get used to looking at the differences between carrying out something in practice and what the theory actually suggests. We also supplement both of those with tutorials and project work and group work. So just to give you a very quick flavour of some of the degree streams, biomedical engineering, which is my own particular area, I came into biomedical engineering having done mechanical engineering and then specialised in what is now commonly called orthopaedic mechanics. But essentially I spent 10 years in the industry designing knee replacements. And you may be surprised to know that Ireland is now the knee manufacturing capital of the world, not just because of what I did, but what a lot of other people did as well. But alongside orthopaedics, Ireland is now internationally known for the work that it does in cardiovascular and active implantable medical devices such as pacemakers and neurostimulators, for example. 250 medical tech companies in Ireland, over €7 billion worth of exports annually, employing more than 25,000 people, which is the highest number of people employed in a medtech sector in any one country in Europe. Chemical and bioprocess engineering is fundamentally looking at transforming raw materials into a specific usable and useful commodity. So, for example, taking crude oil and turning that into petrochemicals, or taking chemical components and compounds and turning them into pharmaceuticals. And that's been one of the significant changes nationally over the last couple of decades, where we've seen the growth of the pharmaceutical and the biopharma industry, and now 9 of the world's top pharma companies are based in Ireland. 12 of the top-selling medicines manufactured in Ireland, and through chemical and bioprocess engineering, obviously, we're feeding and supplying the engineering requirements for those companies, both here and internationally. Civil engineering has been through a slump. It's recovering, and part of that recovery is driven nationally by significant investment in infrastructural and capital development projects. So there's 27 billion euros invested into transport and topically flood defences. I think they might have to increase that budget slightly, together with schools and hospitals and other infrastructural activities. Over the last 2 years, 20,000 jobs created in the construction industry in Ireland. But don't forget, construction is one part of civil engineering. You're also looking at water and environmental as another aspect. So again, you can take the fundamentals of civil engineering and then apply it to a domain that perhaps we wouldn't normally think of as being part of the civil engineering space. Electrical and electronic engineering share many fundamentals, and as you go through that program, the first few years will have the same module offerings, and it's particularly in the last year or 2 years in the ME program that you start to specialise into being either an electronic or an electrical engineer. Fundamentally, electrical engineering is concerned with energy and how you can capture and then distribute the electrical power through the national grid and so on. And UCD electrical engineering is the world leader in renewable power and grid integration. And the work that's done here through the Energy Institute is not only nationally leading, but is a centre of excellence worldwide. Electronic engineering in UCD has an extremely strong and long track record in the area of information communications technology, particularly in digital signal processing and so on. And moving from that background into mobile comms, internet, the Internet of Things, is a natural progression for them. So the ICT sector in Ireland then has the highest concentration of ICT activity in any OECD country, not just in Europe, in any OECD country. We are one of the top 5 exporters in the world for software, and particularly for energy, we have €1.5 billion worth of investment in the energy space and services annually in Ireland. Mechanical engineering, one of the traditional disciplines that's grown to encompass both biomedical, energy and materials aspects, is fundamentally concerned with the design and manufacture of components and systems. And the manufacturing base, although you may not realise it, is extremely strong in Ireland. We have 200,000 people employed directly in the manufacture of products and devices in Ireland, with another 200,000 employed indirectly in support of that activity. Mechanical engineers, along with civil engineers and electronic engineers, are in incredibly short supply across Europe. And particularly for mechanical engineering, they reckon that there's over 40,000 jobs that will require filling between now and 2020. Structural engineering with architecture is a degree programme that we've developed here because of the fact that UCD offers both an architectural degree programme as well as engineering and civil engineering in particular, and it lets us take structural engineers and develop their ability to interact and interface with architects. One question that comes up quite often is, if I do this programme, will I become an architect? And the answer is no, you will not be a qualified architect at the end of this programme, but you will be a structural engineer who's able to work and interface directly with architects, take their concepts and translate them into implementable solutions. And so your main focus afterwards then is working in the construction industry and at that interface between architecture and civil engineering. I mentioned study abroad. UCD Engineering has extremely strong relationships with a wide range of universities ranging from Vancouver through to Auckland. And each year we have students who will either go out for a full year or a full semester. And those students who are particularly keen on skiing have just recently left for Colorado, where apparently they'll be studying hard, but I suspect the ski passes have already been acquired. Part of our ME programme, as I said, involves a 6 to 8 month industry placement, and these are some of the companies that we work with. This year we've placed about 140 students, mainly nationally, and some of these companies initially took 1 or 2 students, are now coming back in their 3rd or 4th year and are taking 7, 8, 9 or 10 students because of the value that they provide to the companies through the work they do in the 6 to 8 months they're with them. Some of these companies are not just multinationals, but some of the companies are actually startups that have come from UCD Engineering. So ResMed in particular is a startup that came out of electronic engineering looking at sleep apnea and sleep disorders, and was acquired by a US company, ResMed, and they now take our interns as part of their further engagement with UCD. Where do UCD graduates go? Pretty much everywhere, but this is a snapshot of some of the companies that I work with. My favourite is the one graduate we have, admittedly only one currently, working with Ferrari. I'm waiting for the invitation and for the free Ferrari, but that's not happening just yet. So in closing, what would I say about UCD Engineering? The key points I'd like you to remember are that we have an incredibly wide range of programme offerings, and we don't expect you to make your decision about your final degree at the end of your first year. You make one decision at the end of your first year, you make another decision at the end of your 3rd year, and you have this ability to gradually specialise and to choose between the programmes that are available. The degree programmes we offer are accredited. They are internationally recognised, which means you have the ability to travel and work abroad once you graduate. The programmes are delivered by academics who are internationally leading in their field, who generate significant research income and use the knowledge and experience they gain through their research activity to inform the degree programmes, particularly in the later stages where you're looking at the more advanced aspects of any particular topic. We have study abroad opportunities. We have extremely strong employment prospects and track record, and alongside that we also have supports that help students get through the programmes at different times. Student supports, but also the social supports through the clubs and societies. And some of you who may not know this campus very well, it is the largest urban campus in Europe, over 130 hectares, but we have, over the last 10 years, developed a fantastic campus which includes not just new academic buildings like the Sutherland School of Law, but also the Student Centre with its 50-metre swimming pool, theatre, debating chamber and everything else. So as an engineering student, you're not going to have huge amounts of time to go and do other things, but we expect students to engage in clubs and societies and to benefit from the wider UCD community as well. So I'll leave it here. I won't take questions now. I think we'll have questions at the end. Thank you very much. And now I'll hand back to Jonathan. Thanks.
Thank you, David. I should have mentioned at the outset that we will have a Q&A session at the conclusion of the 4 presentations. So we can just hold back and there'll be plenty of time for questions at that time. So the next speaker is Dr. Aisling Harkin, Aisling is the Deputy Director of the UCD Careers and Development Centre, and Aisling is going to talk to us this evening about, or give us a flavour of the sort of employment opportunities and careers that are available to graduates of the engineering programmes in UCD.
Hi, good evening. My name is Aisling Harkin. So I'm the Career and Skills Consultant, the dedicated Career and Skills Consultant for the College of Engineering and Architecture. I'm delighted to be here this evening. I was asked to just briefly present to you some of the opportunities, specifically career opportunities related to engineering here within UCD. Okay, so why engineering? David has covered this very strongly, but I thought it was good to pull some key points together from a careers perspective. Obviously, engineers take ideas, raw designs, and turn them into reality using ingenuity, creativity, and their science, math, and technological skills. But why engineering for you, and why potentially could it be a good choice? So one of the key things is, in terms of your career moving forward, it offers you huge flexibility. The numbers of areas and specialisms that David touched on there just before me, but also the expanded areas. So it's not just within engineering sectors that employers are interested in engineers. It's actually much broader than that, and we'll talk about that as we move through the presentation. It is one of the most important growing sectors for graduates, as David mentioned. There's a lot of skill gaps now as we see the upturn in the economy. So there's huge employment prospects moving forward in a number of the different areas, and we'll look at that as we move throughout the course of the presentation. An engineering qualification absolutely travels very well. Technical language is a global language, and a lot of our engineers have taken the opportunity to go abroad throughout their degree and then take up a global graduate opportunity as they move forward. As you can imagine, UCD is a global brand that's received well throughout the world. It remains one of the best paid sectors here, according to Grad Ireland and the research, and some of you might be interested in that. The average salary is typically starting at $31,000 to $34,000 for graduates currently, and that is expected to rise. It does rise very quickly. Within the first 5 years, those graduates do achieve $42,000 and beyond, approximately. And engineering, typically CEOs within Ireland, about a third of those have an engineering qualification. So the prospects are very, very strong moving forward, and it's important to some people to emphasise that. Just to look at the stats in terms of what it looked like for the class of 2014. This is research that we do on an annual basis. It's our First Destinations Return Survey, so we're required to do that across Ireland. And really we're performing significantly above average as a college here. So as you can see, 77.9% of graduates that were surveyed just 9 months out of their degree are in full-time employment. With some of the top global firms that we'll look at as we move forward. 8.1% have chosen to go on and do postgraduate study, a PhD perhaps, and then there's 14% that are still considering their options, finding their way and pathway. As the Career Development Centre, we offer 2 years postgraduate experience, so if you're having difficulty with employment, you can offer or take up that option of coming back, and we can give guidance, one-to-one appointments, etc., on finding that. Just in terms of those graduate employers, this just gives you a flavour. You've seen a few already. Just from the different areas, the different sectors, as you've already heard, 9 out of the 10 top pharma companies, 9 out of the 10 top software companies housed here in Ireland. Construction is a massive area now that's building pace. Mechanical engineering is a significant area that there's skills gaps in. These are just some of the global companies that our interns and graduates have been placed with over the last couple of years. And it just shows you the flexibility that's there. You'll note actually that some are not all engineering based. There's some finance houses there, consultancy houses, investment banking institutes, and essentially engineering, it's a qualification that goes right across sectors. It's in high demand in consultancy, investment banking and finance, as well as your typical engineering sectors as well. And they want those graduates for their creativity, their imagination, their teamwork and problem-solving skills. So it's an excellent transferable degree, as well as within the sector and beyond the sector. Okay, just to give you a flavour of what employers are saying, we can't fit all their comments on the screen, but I just tried to pick on different sectors for you. As David mentioned, we do have an internship programme here within the college, and there's a 6 to 8 month internship opportunity for those in the ME programme, which gives them a fantastic insight into the real world of work and gives them a flavour of what it's like to work in a particular sector. Employers' feedback has been hugely positive. And that's really important as we build the number of internship places, and it's really only on the rise in terms of internship offerings that we have. Something that's important to say now, that employers are increasingly using the internship method. It's becoming basically a long-term interview process for them. About 80% of graduate employers will look towards internship programs for their graduate hires. So it's a fantastic opportunity to actually bag yourself a graduate employment job at the end of it. And sometimes our students come back and they know that that's not what they want to do, and actually that can be a really rewarding experience because they've spent 6 to 8 months and learned that and are happy to then look in a different direction and a new sector potentially. So it can work in a number of positive ways. It is important for you, as you're about to come into the university, to think about how you are going to differentiate yourself. There's a lot of people in this room, and typically you will have a lot of peers that are coming in, that come in with very high points, that are very enthusiastic, that are high achievers and do very well for themselves. It is difficult for employers at the end of that process after your degree to select who is the best candidates for them. A lot of students do quite well actually within their degree and achieve a 2-1, which is 60% or above, and that's usually the baseline for a lot of the graduate employers that we work with. So you have to ask yourself, how else can I be different? What else can I add to my degree to potentially help me stand apart from the rest? I'm just going to show you just a very short video that depicts a character, Lucy. It was actually made by students within UCD, of how to encourage students to get more involved and use the services that are available to them within UCD to maximise their career opportunities. perfect graduate, obviously your degree is fundamental and you need to excel in that, but it is also looking at other ways that UCD can offer you other opportunities to maximise the person coming out alongside the academic achievement. So in terms of transferable skills, volunteering opportunities, actually understanding what role or sector you're going into, you can imagine the internship experience gives you a fantastic insight into that. We also support you in work experience right throughout your university degree experience, whether that be in internships, both internationally or at home summer internships before your academic internship. So there's lots of ways, and we'll go into that in a little bit more detail. The Career Development Centre are keen to talk with you from first year onwards about your roadmap to success. Because this all doesn't happen in final year. You're very, very busy and you have lots to do in final year, and that's where you're really focusing on that academic achievement. But really from first year onwards, there's countless opportunities that you could look at. In terms of clubs and societies, volunteering, there's UCD volunteering abroad opportunities as well as internships, part-time jobs, and recruitment fairs. So we'll just look at what UCD can offer you in terms of maximising employability skills moving forward. So in terms of clubs and societies, there's up to 200 plus of those here within UCD, so that essentially there's something for everyone. Volunteering is part of the culture here, civic engagement within UCD, and we're constantly promoting that. Obviously, I've mentioned as well there's volunteering abroad opportunities. We have a specific programme targeted at that, where students go to Uganda, Ghana, etc., all parts of the world to help various different communities. We specifically target 4 annual recruitment fairs. That attracts 160 plus graduate employers on campus to meet and talk to students just like yourself in terms of employment opportunities, both internships and graduate opportunities after your degree experience. One of those is dedicated to science, engineering and technology. It's one of our most popular ones. And in total, we attract about 4,250 students to those recruitment fairs on an annual basis, so they're very, very popular. Throughout the year, it doesn't just stop at recruitment fairs. There are recruitment presentations, so 118 of those took place last year from employers both within the engineering sector and right across sectors. So to give you a flavour both within your own discipline and beyond disciplines as well, you can go up and talk to them face to face and get a feel for what their companies are about and what the culture of that company looks like. We do bring employers on campus to deliver skills-based workshops, so where you potentially feel there may be gaps in certain skills that you have, you can go and learn those skills from employers that lead them. Obviously, this gives you an excellent way of actually talking to employers firsthand, and again, finding out a bit more about the company that they work for and getting a feel for that sector. Recently, a pilot that we've looked at from last year onwards is alumni career mentoring. A lot of our UCD alumni are keen to give back to UCD, which is fantastic, and they want to talk to prospective students like yourself in terms of career opportunities moving forward. So that's another thing that we're exploring. In terms of career coaching and guidance, we have a number of career and skills consultants that offer one-to-one appointments to talk through your CV, interview techniques, potentially what you want to do with your life. We get a few of those questions. So we've met about 3,000 students last year, and we're building on that, and we're hoping to focus on more resources in that area. We do run personal and professional development programs within modules and co-curricular models alongside modules as well. So we have engaged with about 7,600 students through that means. Obviously the academic internships we've mentioned, we support them heavily, and we do support heavily the ME internship also. So you will be coached through strong applications, CV advice, mock interviews, etc., just to give you a flavour of how to really impress those employers before going out, because often this is the first experience that you've had of a formal interview, and we help you through that experience step by step. There's also online resources that are heavily accessed, that if you want to do psychometrics testing, if you want to look at global opportunities, and we advertise up to about 2,500 internship and graduate positions on an annual basis. So there's lots of opportunities there to maximise your degree moving forward. Just a final word from me. Really make your time count when you are at UCD. Use your Career Development Centre and all the resources that are available to you, because there are a huge amount there. I wish you every success moving forward in your examinations, and I look forward to working with you in the future. Thank you very much.
Thank you, Aisling. Some of you may be considering engineering but haven't quite decided. Some of you may have already decided that you're going to study engineering but haven't quite decided what discipline you're going to study. So there are decisions that have to be made in choosing engineering and then choosing while you're in UCD studying engineering. Our next two speakers are going to shed light on how they made those decisions. So we've got two younger people, a recent graduate and a current student. And we're going to begin with the current student, who's Ruth Quinn, and she's a fifth-year student of biomedical engineering.
Thank you. I'll just start this. So, hi everyone. So my name is Ruth Quinn. I'm a biomedical engineering student and I'm currently in my 5th year. I'm just going to tell you a bit about my experience of engineering throughout the years, and hopefully it'll be helpful and answer a few questions. So where it all began, basically I was like a bit of a creative child. I loved like drawing, making things, and Lego was like the choice, or the toy of choice basically. But in school it was always maths, and then from transition year on I kind of realised I liked science subjects. So like you probably saw that the BT Young Scientist was on last week. So I competed in that in transition year, and what I liked was like working in the lab, getting results, then presenting your results to the judges and everything. And that just being exposed to the companies that were exhibiting there as well, also kind of started to realise I had an interest in science, but again, wasn't really sure what I wanted to do. Also in 4th year, I did work experience in a company in Wexford. So I was just like, got to follow around an engineer, see what they do, and basically, so I got to like play around with CAD. They let me like work some laser cutting machines. I didn't really know again like what an engineer did, but it was just another option. So it's kind of like the creative side, science and engineering. That was a bit. So when I was choosing my subjects for the Leaving Cert, I kind of wanted to keep my options open. So I chose physics, just in case, biology, because I wasn't sure whether I wanted a health science subject, study health science subject in college, and then applied maths was just an extra one. So going into 1st year engineering, as Professor Fitzpatrick said, it's not a requirement to have physics. You can definitely make it through it without it. The only requirements are that you have honours maths and a minimum of a C3 grade in that, and then one science subject. So don't worry, you've got 2 physics modules, one in semester 1 of 1st year and one in semester 2, and then they're kind of like fast-tracked through the Leaving Cert course, and there's also lots of sports in like the Math Sports Centre. There's TAs and tutorials that will be able to help you if you're stuck in any way, so don't worry about that. So then, if you pick engineering, you start off with your orientation. Firstly, you get split up into peer mentor groups, so it's about 14 people, and you have one peer mentor. They'll show you around, show you the ropes. They'll show you the library and all those fun things, and it's basically just, you can also like meet people through that, so it's good if you're the only person coming from your school. It's just a nice way to kind of meet a few people before you actually go into the lectures. In 1st semester, you'll all be doing the same 6 subjects, so you'll all be together. And then in 2nd semester, you've got 3 cores, 1 option module, which is choice between chemical module, design materials, and a computer science. And then you've got 2 electives. So again, Dave Fitzpatrick was saying that you can choose these from any section of UCD. You can choose if you want to continue on a language. So I chose Japanese because I had studied that for my Leaving Cert, and also robotics. engineering is tough in first year. It's quite like a jam-packed course. You have to spend a lot of time in college, but there's also a lot of things outside. So EngSoc are great at organising like the Eng Formal, which was before Christmas. They also organise Eng Ball after Christmas, and we also have this stretcher race, which is like a charity fundraiser where you dress up and run around town like hooligans, basically. And so they organise loads of things like that. There's also class trips. So you'll have one in each semester usually in first year. They're organised by your class rep. So it's a social course. You won't be left by yourself. You'll have loads of opportunities to meet people. And also, in college, there's also group projects and lots of labs and stuff. So after first year then, you choose which stream you want to go into. So mechanical, electrical, chemical, and civil, and I chose biomedical. So for biomedical in second year and third year, you basically do kind of a mixture of modules. So you study some mechanical, some electrical, and some physiology modules. So just as an example, these are some of the modules that I studied. Applied dynamics, mechanical engineering design is where you use like CAD to draw that. It was something that I did. I don't really know. I can't really remember exactly what it was for, but yeah, that was like some things that you did. Mechanics of solids. And then for the electrical modules, so we did electrical, electronic circuits, electromagnetics, and computer engineering. And that computer engineering is like coding, so it's a continuation of computer science that you can choose in first year. Then onto the physiology. So if you pick biomedical, you can also join in with other sport and human performance courses. So that was science human performance, that was what I studied, and functional anatomy, which is you study different parts of the body, muscles, what actions they do, and like stretches for them and everything. That was a 3-hour lab like once a week. So UCD has so many international connections with some of the best engineering colleges in the world. You get the opportunity to go on exchange in third year, and a lot of engineering students take it. So I actually went to the University of Texas at Austin for 1 semester, but I also had friends that went to California, Beijing, Singapore, Vancouver. The options are endless, and they actually count towards your degree. So if you go for a semester, they count for 30 credits, and if you go for a year, they count for 60 credits. And you just have to pass all your exams. If you don't, I don't know. So after third year, you can either leave with a BSc, so a Bachelor of Engineering, or Bachelor of Science in Engineering Science, or you can continue on to your fourth year to get a Bachelor of Engineering. Or you can choose after third year to pick the Masters. So the Masters consists of 2 years. Your first semester will be quite specific to your discipline. So that's just an example. I did medical device design, biosignal processing, biomaterials, and biomechanics. And then for the second half, you go on your internship. So that's like very essential when you're leaving college that you have real work experience. I did my internship over in a small company in Galway called Crossbon. They took on 4 biomedical engineers, but we are all different disciplines, basically. So I was the electronics and hardware engineer, John was software, my other friend was mechanical, and there was manufacturing as well. And we all had different roles and responsibilities. So when you get in there, though, you are a fully fledged engineer, basically. They don't treat you like you're a student. You're not going to be photocopying or doing coffee run or anything. Myself and the software engineer actually developed that board, so I designed it, manufactured it over in China, not myself personally, but got it manufactured, assembled it and did all the testing. And then my friend John hooked it up. He used software to basically, he could control it using iPhone app. So that was what we developed on our internship. Now that I'm back, I'm in 5th year. So I have a thesis. It's worth 20 credits of my 60 credits this year. And it's just, I won't go on too much about it because it might be a bit boring, but It's on the variation of ECG signals with concentration of blood glucose. So this is quite like a practical project. There's lots. I'm testing at the moment where I have participants cycling for 2 hours, and then I monitor the ECGs and also monitor their blood glucose. And then this, in turn, is part. I'm just going to take a breather. Is part of a bigger project with the aim to develop a non-invasive wearable sensor to monitor blood glucose for diabetic patients. So it uses ECG, muscle activity, and temperature and perspiration. So then, what is next? So the future is bright if you choose an engineering degree. I know you've kind of seen this. You've seen this slide in all the other presentations as well. But if you leave UCD with an engineering degree, the options are endless. You can travel with it. You can work wherever you like. If you have a language, if you studied a language for Leaving Cert, you can keep that up through UCD. You can also work anywhere you like. I know a lot of people do go into engineering, but you can also go into consulting. There's the big four, like PwC, Deloitte. They all take on nearly as many engineering graduates, I think, as they do business graduates. So, there's a lot of options out there, basically. So that's everything from me. I'll be here after if you have any questions. Thank you for listening.
Thank you, Ruth. Last but not least, then, again to give a flavour of something similar but a little bit different nonetheless. Our final speaker this evening then is going to be Conor O'Malley, and Conor is going to be giving us the perspective of a recent graduate of electrical and electronic engineering in UCD.
Hello. So my name is Conor O'Malley, and I graduated from UCD in 2013. And I'm going to just tell you a little bit about kind of what you can do with a degree from UCD, based on what I have done. So I did the bachelor's, the more traditional degree at the time, between 2009 and 2013. Ruth has already told you about what it's like to be a student, so I'm just going to give you kind of the quick highlights of what I did as I went through it. So I entered in year one through the omnibus, where you get a good flavour of all the different types of engineering you can do. So after seeing the different options, I decided that I liked electrical and electronic the most, so I chose to do that in year two. In third year then, like Ruth again, I went to do the study abroad, so I went off to Georgia Tech in America, and it's kind of one of the top 10 engineering universities in America. So I got to go over there and kind of see how well I was doing kind of on an international scale. And you have to pick out some classes, and like Ruth said, you just have to pass them. But I found that from my first and second year in UCD, I had covered the fundamentals so well that doing that was relatively easy. So UCD was good in that sense. Third year as well, there came up an opportunity to do a course in Aarhus University, which is in Denmark. So I got to go there for 2 weeks and participate in some classes, and that got to count as another class back in UCD. So it's one less class to do. And then after all this, I came back from all the traveling and decided to become an electrical engineer. So while I was studying, every summer I did a lot of different internships. And this is a great way to take what I'd learned in college and bring it into the outside world and see how it was applicable and to get some experience and, probably more important, to get paid as well. So in first year, I went to work for ESB Networks. So you probably heard of them. They kind of deliver electricity to everyone's house. So I went there for the summer, 3 months, and I worked on their smart meter project. So it wasn't just photocopying or making coffee. I actually got to do some work and contributed in a real way. In second year, I went to work for a different company called Into Networks, and this is a company that it's an Irish startup, and it was started by two guys who came from UCD, and it was kind of based around the internet and making the internet faster. And again, I got to do some work to help them sell their product, and it was useful. You felt important, and what you're doing was good work, and you're getting paid, even more important. Third year, so this is when I was in America. I decided to, after I did the semester abroad, I stayed in America and got a job in an American company called EPRI, so they're the Electric Power Research Institute. and they do a lot of the research for all the big American utilities. So when I was there, I got to do a lot of work with a lot of renewable energy kind of stuff. And finally, after my 4th year, I went to work for another Irish startup called Electroroup that has some ties to UCD as well. And they're an energy trading company, so they buy energy in one company and sell in one country and sell it in another. And I got to work there as an analyst. So it's over the 4 years, I got to do a lot of different work. I got to work in startups. I got to work in more established companies. I got to do research. It was all very interesting. And it wouldn't have been possible without the degree I was doing in UCD at the time, the electrical engineering. So when I finished my bachelor's, I decided to go and do a master's. And I did it in the European Union under a European funded kind of thing. And it was 2 years. The first year you spent in one university. I went to KTH, which is a university in Stockholm in Sweden. So this is another, it's like top 10 university in Europe. And so when I went over there and joined the class that had a lot of other international students that were all in a similar position as me. They'd just done a bachelor's degree in their home university, and they came to Stockholm to start a master's. And what I found overall at the end of it was that all the different classes I had to do and all the different projects that I'd been very well prepared for it in UCD. I knew the fundamentals well, and I had a good broad base of knowledge that I could draw on. And that kind of maybe wasn't so much the case from some other students from some different countries. In between the 2 years, part of the program is you have to go to a business school in UCD, which is in Barcelona. You think an engineer in business school kind of in trouble there, but in the bachelor's in UCD, you do actually have to do some business kind of based courses. So you do a little bit of economics, you do a little bit of law, a little bit of management, and these actually turned out to be quite useful, and they were able to help me get through this UCD course as well. Second year then, I went to a different university, TU Eindhoven. If you've ever flown to Amsterdam with Ryanair, Eindhoven is the city you go to. So it was, again, it's a similar situation to KTH, a lot of international students, and I found that I could draw on the stuff that I'd learned in UCD, and it was very useful and it was very helpful to get me through that. And then for my master's thesis then, I went to work for Alstom, which is a big multinational company. One of their divisions makes the tram for the Lewis, so you might have seen their logo there. But so this was based in the UK. I got to go over there and spend a couple of months working in the UK with some UK graduates, and again, I found that I was perfectly up for the job and did very well at it. So after all this, I decided to come back here and get a job. So I went to work for Gay Electric, which is a renewable energy company. So they kind of deal a lot with big wind farm projects and things like that. I joined their energy storage team, who they do a lot of different things, but one of the areas they're in is batteries. So they do some work with Tesla Motors, if anybody's ever heard of them. They make the very fancy electric vehicles. So I get to, at the moment, do a lot of work kind of based around the electric vehicles and home storage and things like that. So that was kind of what I did with my degree. And I'll just tell you a little bit about what some of my classmates did as well. So the kind of stereotypical jobs for an electrical engineer might be to go to work for ESB and Airgrid, and a few people did do that. Another person went off to work for the PM group, so it's a project management group. And while they were working for the PM group, they were able to study and do a master's as well, and now they've just moved off to San Francisco with the PM group. Another option then is to go into accountancy. So somebody went off to join PwC and they've started to do their accountancy exams. Another option is to go to work for SIG as a trading company. So they trade in commodities. So another graduate went off to go work for them. Another graduate didn't want to go right into work, so he went off to Japan to teach English for a while. So you really can't do anything you want, but they did eventually get a job in Japan as an electrical engineer working for a company there. And of course, there is another option, is to stay in UCD and do a PhD, and there is a few people who have done that. So there's really a very, very wide range of opportunities, different countries, different jobs, lots of possibilities. So why would I recommend you to do engineering? One of the main reasons is the very strong focus on the fundamentals, and I found that this was the most helpful thing in everything I've done, is that the stuff that I learned very early on in UCD, came up again and again and again. Because you learn it first in UCD, it's easy to do again and again and again. Second is you develop analytic skills. You don't even know that you're doing it, but by the end you know how to think like an engineer, I suppose. And companies value this an awful lot, and it's why a lot of companies will hire engineers just for the way they think, and it's because of these analytic skills that you've developed. So another reason is that there is great opportunities for traveling and work. So I always traveled around a lot. I got to do a lot of different work, and all of it was kind of possible through this degree from UCD. So the bottom line is that it just is an incredibly versatile degree. You really can do almost anything you want with it, and so that's really why I'd recommend it. So, thank you.
Thank you, Conor. We have some time now for a Q&A session. There will be opportunities out in the foyer to ask specific questions or questions maybe that aren't answered in this Q&A session. So there will be again an opportunity at the end of this session, if you like, in the lecture theatre to raise some issues. So what I'm going to do is I'm going to get the speakers perhaps to come up to the podium here, and we will then see, are there any questions that people have and wish answered? Yeah.
Yep. So there is a GPA threshold that you have to pass. Now, at the moment, it's not set at a ridiculously high level. I mean, this year, I think close to 70% of the students have progressed onto the ME program, and they're the ones who wanted to progress. The others have decided to do the BE route. So there is a progression threshold that's there to, keep a very high academic standard in the ME program. It also means that we have a barrier to stop people coming in from outside who might swamp the program if they just came in with any degree they wanted. So,
have we any other questions? Yes.
Sorry, I missed that.
The rate of dropout.
Sorry, the question was, what's the dropout rate in first year engineering? After first year. Topical question. Unfortunately, I was travelling, so I didn't get to see the Irish Times article on dropout rates. UCD Engineering actually is incredibly proud of our progression record. Students, we find that there are a number of students who will leave in first year, typically quite quickly will decide, actually, this isn't what I want to do, or may transfer at the end of first year to another program. But, I mean, our progression rates overall are in the 90%. I mean, we have single-digit non-progression. So, yeah. Yeah. The question was, what are the fees for fourth and fifth year? So the way we've structured the degree program is that fees are payable in fifth year only. So they would be whatever the EU fee rate is, which at the moment is around about €7,000 euro for the fifth year only. And that's the HEA will pay the fee for the first 4 years.
Yes.
So the question relates to people coming into engineering programs having studied abroad or with other qualifications. And so students who arrive into our programs with previous experience or as a mature student, we would normally look at their previous education record and may give them some credits for the work they've already done. We'd have to do it's always done on a case-by-case basis, and we map our curriculum against whatever anybody else has previously done. So that's typically for the sort of mature entry route. Yep. Is it 25?
Yeah, it varies a little bit year on year, but it's of that order of magnitude. We certainly haven't had a year where we've taken more than 25 students. So it typically varies, I think, between 15 and 25. Yes.
So the question was, for either of the students, what do you consider to be the most challenging part? Ruth hasn't finished yet. Maybe that's unfair.
Yeah, I've finished too long ago. I'm trying to remember now. I mean, I didn't do physics in secondary school, so when I came in, I did have to learn physics kind of from scratch. So that was the first two. In the first year, I did 2 modules of it. That was relatively tough, just because I hadn't done it before. But it's not impossible, and it is a good way to learn it from in college, because you learn everything you need to know, as opposed to maybe from the Leaving Cert, where you didn't learn everything just enough to get you to the Leaving Cert.
Okay, we'll spare you.
Yeah.
Yes. So the question relates to the study abroad year and how that affects the calculation of your degree GPA. And it's a little bit detailed, but the simple answer is, if you were to take a full year abroad in your 3rd year, and you were then to go and take the 4-year degree program and graduate at the end of your 4th year with a BE, your degree GPA would be calculated only on the basis of your 4th year subject modules. Because students who study abroad come back with the credits, but the grades aren't included or counted towards their degree program here. We count the credits, but not the grades. So they must pass, but the grades are, to that extent, not really relevant for the degree.
So yeah. 5-year ME degree is that 5th year, that isn't kind of giving marks, it's just a master's, so you're still then on 4 years.
No, I think it'll get a bit more complicated if we start talking about the ME program as well, so we can talk about that later. But the typical approach within the degree programs here is that your degree GPA is calculated on a weighted basis for the last 2 years of your program. So your ME degree within the current degree programs is 30% in your stage 4 credits, 70% plus. Or no, that's a 1 stage, isn't it? You're right. Anyway, see, even I'm confused. It's, anyway. Yeah. So the question is what links we have with aerospace. Our strongest links with ESA are through the research programs. We would have ESA-funded research in materials or in dynamics and other areas. We have certainly employment links with Rolls-Royce Aerospace, as well as automotive. So yes is the short answer. There are links. Yeah.
Yes.
I asked the graduate student there, was it easy for them to get relevant jobs every summer? Did everybody get that, or was there any other?
Yeah, I was maybe a little industrious working every summer. About getting jobs, a lot of opportunities come up. You can go and talk to professors, or else they're getting a lot of speakers during the year to talk about what their company is, and you can go up and ask them at the end of the talk if they have any jobs going, basically, and try to start networking that way. So yeah, if you go looking hard, you will find something that you can do.
Okay. If there are no further questions, then I think we'll wrap up the main activities for the evening, or at least the main activities in this lecture theatre. As I said earlier, there'll be an opportunity still to ask questions out in the foyer. And before you all go, I just want to thank you for coming. I hope you found it informative. But if there are any questions or issues that you have subsequent to this event, you can ask any of us through email or the programme office through email. So don't be afraid of firing off an email to us if something pressing comes up in the aftermath of this event. So thank you very much.